In 1970, the Soviet Union sent a spacecraft to Venus. Titanium armor, advanced cooling systems, built to survive conditions that would destroy any machine. It lasted 23 minutes. 23 minutes before Venus completely destroyed it. Here's what terrifies scientists. That probe didn't need to breathe, didn't need to stay warm, didn't have a heart to protect. Now imagine what Venus would do to a human body. Actually, you don't have to imagine. Scientists have calculated exactly what happens, second by second. What they found made every space agency on Earth abandon any plans to send humans there, permanently. Today, I'll show you 4 reasons why Venus is impossible. But the 4th reason, that's the one nobody talks about. It's not about temperature, not about pressure, it's about what Venus used to be. And when you understand that, Venus becomes more than just a hostile planet. It becomes a warning. Let's begin. Venus is the closest planet to Earth, just 40 million kilometers at its nearest point. Compared to Mars, it should be easier to reach, shorter journey, less fuel required, more launch windows available. And Venus looks almost peaceful from space, pale yellow clouds, soft glow, named after the goddess of love. But beneath those clouds lies something else entirely. The Soviet Union discovered this the hard way. Between 1970 and 1984, they sent multiple Venera probes to the surface, each one more advanced than the last, each one designed specifically to survive the most extreme conditions known in our solar system. Venera 7 lasted 23 minutes, Venera 9 managed 53 minutes, Venera 13, the most successful, survived 127 minutes, just over 2 hours, then Venus destroyed it completely. And those were machines, armored, engineered, no biological weaknesses. A human being is infinitely more fragile. So what exactly makes Venus so deadly? 4 factors, each one alone would make survival impossible. Together, they create an environment that simply does not permit human existence. Let's start with the first one, and this alone would end any mission instantly. The atmospheric pressure on Venus is 92 times greater than Earth. That number sounds abstract. Let me make it real. Imagine diving into the ocean. At 10 meters depth, you experience double the normal pressure. Your ears pop, your body adjusts. At 100 meters, you need specialized training and equipment. The pressure starts affecting your lungs, your blood, your thinking. At 300 meters, only the most elite divers can survive, and only with extensive preparation. Venus equals 900 meters underwater. No human has ever survived that depth. No submarine operates there. The pressure would cause immediate physiological trauma. Every airspace in your body would be affected simultaneously. The Soviet engineers understood this. They built the Venera probes like underwater vessels, not spacecraft. Thick titanium shells, reinforced joints, pressure-resistant electronics. Even then, the pressure found weaknesses. Seals failed, joints compressed, systems stopped working. But here's the strange part. Pressure alone didn't destroy those probes. They were designed for pressure. They could handle 92 atmospheres. Something else contributed to their failure. Something the Soviets prepared for but couldn't fully defeat. We'll get to that. First, you need to understand the second factor, because when pressure combines with this next element, that's when Venus becomes truly impossible. The surface of Venus maintains an average temperature of 465 degrees Celsius every second of every day, everywhere on the planet. Let me put this in perspective. Your kitchen oven reaches about 250 degrees maximum. Most people consider that extremely hot. Touch something at that temperature, and you'll have serious burns instantly. Industrial furnaces that melt metal operate around 500 degrees. Venus sits right between those, a planet-wide furnace that never turns off. Here's something to think about. At 100 degrees, water boils. At 200 degrees, most plastics melt. At 300 degrees, lead becomes soft. At 465 degrees, lead flows like water. Zinc melts. Electronic solder becomes liquid. Any standard material fails. And here's what most people don't realize. Venus is hotter than Mercury. Mercury orbits much closer to the Sun. It receives far more solar radiation. It should be the hottest planet, but Venus beats it by almost 200 degrees. Why? Because Venus has an atmosphere, a thick blanket of carbon dioxide that traps heat and never lets it escape, a runaway greenhouse effect that has been cooking the planet for billions of years. The Venera probes carried cooling systems, compressed gas that would absorb heat and keep the electronics functioning. These systems worked for about 2 hours, then the heat overwhelmed them. Temperatures inside the probes rose beyond operating limits, circuits failed, sensors stopped responding, the probes went silent. But even temperature wasn't the only factor attacking those machines. There was a third element, one that was actively eating away at their protective shells from the moment they entered the atmosphere. And this one is genuinely disturbing. Look at Venus from space and you'll see clouds. Soft, yellow, almost beautiful. They reflect sunlight and give Venus that characteristic glow that ancient civilizations associated with beauty and love. Those clouds are made of concentrated sulfuric acid, the same chemical used in industrial processes to dissolve metals, the same acid that can eat through materials that nothing else can break down. These clouds stretch from about 45 to 70 kilometers above the surface. Any spacecraft passing through spends hours being bathed in acid. The Venera probes needed specialized coatings just to survive the descent. Acid-resistant materials covering every exposed surface, seals designed to prevent any acid penetration. Even then, the clouds found weaknesses. Protective coatings began degrading during descent. Joints that seemed secure on Earth developed tiny gaps. Seals that passed every test failed under actual conditions. By the time the probes reached the surface, they were already damaged, already weakened, already failing. For a human in a spacesuit, the implications are clear. Any suit breach means acid contact with the body, and sulfuric acid reacts violently with organic tissue. It generates heat as it destroys. A small tear in a suit that might be survivable on Mars becomes catastrophic on Venus. But you wouldn't get that far anyway, because the suit itself would be under attack from the moment you entered the atmosphere. Hour after hour of acid exposure. No material we can practically build would survive long enough to matter. So let's summarize what we know. Pressure equal to 900 meters underwater. Temperature hot enough to melt metal. Atmosphere that actively dissolves protective materials. Each one alone would make human survival impossible. Together, they create an environment that attacks from every direction simultaneously. But here's what's strange. We've covered pressure, we've covered temperature, we've covered acid, 3 impossible barriers, 3 absolute guarantees of mission failure. And yet none of them is the fourth reason. The fourth reason is different. It's not about what Venus is now. It's about what Venus used to be. And this is the one that will stay with you long after this video ends. 4 billion years ago, Venus may have had oceans. Read that again. Oceans, liquid water on the surface, waves breaking on shores, water cycling through an atmosphere. The evidence comes from multiple sources. Measurements of hydrogen isotopes in the current atmosphere suggest massive water loss over time. Computer models show Venus could have maintained moderate temperatures for billions of years. Some scientists believe Venus remained habitable until as recently as 700 million years ago. This means something profound. Venus is the same size as Earth, same basic composition, formed from the same cloud of gas and dust around the young sun. If any planet in our solar system should have developed life alongside Earth, it was Venus. Our sister planet, our twin. So what happened? As our sun slowly increased in brightness over billions of years, Venus received slightly more energy. Temperatures rose by small amounts. Ocean water began evaporating faster, but water vapor is a greenhouse gas. More water in the atmosphere trapped more heat. More heat caused more evaporation. More evaporation created more water vapor. A feedback loop began, and once it started, it couldn't be stopped. The oceans boiled away over millions of years. The hydrogen escaped into space. The carbon that had been dissolved in oceans and locked in rocks was released into the atmosphere. More carbon dioxide meant more heat retention. More heat meant more carbon release. Venus transformed from a world with potential into the furnace we see today. And here's why this matters for Earth. We're currently adding carbon dioxide to our atmosphere faster than at any point in human history. Global temperatures are rising decade after decade. Now, Earth won't become Venus. We're farther from the sun. Our conditions are different, but the mechanism that destroyed Venus, that mechanism exists. The physics works wherever the conditions align. Venus isn't just a hostile planet. Venus is a message written across an entire world, a reminder of what planetary atmospheres can become when the balance shifts too far. When scientists study Venus, they're not just studying another planet. They're studying a possible future, a warning that has been waiting for us to understand it for 4 billion years. The goddess of love became the planet of destruction. Earth's twin became Earth's cautionary tale. And that is the fourth reason: not pressure, not temperature, not acid. The fact that Venus didn't have to be this way. It chose this path, or rather physics chose it. And once that path began, there was no going back. So let's return to where we started. The Soviet Venera 13, the most successful Venus lander ever built, titanium armor, cooling systems, acid-resistant coatings. It survived 127 minutes, just over 2 hours before the environment completely destroyed it. A human body has none of those protections. We need specific temperature ranges. We fail outside of them quickly. We need specific pressure levels. We fail outside of them instantly. We need protection from chemical attack. Our skin provides almost none. We need to breathe. Venus offers only poison. Scientists estimate that an unprotected human on Venus would remain conscious for approximately 1 to 2 seconds. The combination of pressure, temperature, and atmospheric toxicity would cause immediate physiological failure. Even in a state-of-the-art spacesuit, survival would be measured in minutes at most. The same conditions that overwhelmed Soviet probes would overwhelm any wearable protection. Venus will continue to be studied by robots. Orbiters will map its surface. Specialized probes will briefly descend through the atmosphere. We will learn more about this world, its history, its transformation, its warning. But human footprints will never mark that volcanic surface. Our closest neighbor remains forever beyond our reach, a world that could have been our second home, a world that became something else instead. The next time you see Venus in the sky, remember what you've learned today. That soft yellow glow hides acid clouds. That peaceful appearance masks crushing pressure. That familiar brightness conceals temperatures that would end any mission in seconds. And beneath all of that lies a story of a planet that was once like ours, a story that became a warning. Venus, beautiful from a distance, impossible up close, and a reminder that not every world is meant for us.